Hello everyone, myself Nishant Kumar Karn and I am a second year undergrad student from National Institute of Technology, Agartala. This is the 12th lecture of the topic that we are dealing with, that is electrostatics. So let's get started. So as you all heard, this is going to be our 12th lecture and the topic that we are going to deal with today is electric field due to charged spheres. Now for solid conducting, hollow conducting and hollow non-conducting, the charges will be considered on the outer surface of the sphere. As we have already discussed in case of cylinders as well, for hollow conducting, hollow non-conducting and solid conducting cylinder, the charges were considered on the outer surface of the cylinder, and for solid non-conducting cylinder, the charge was distributed throughout the cylinder. Same is the case with spheres. For solid non-conducting spheres, the charges will be considered throughout the sphere. Now, the derivation for electric field due to solid conducting, hollow conducting and hollow non-conducting sphere. First of all, let us see what happens inside the sphere. Inside the sphere, let us consider a concentric spherical shell. Here, the blue sphere is the concentric spherical shell that we are discussing about here. Now, we know that the total flux through this sphere will be charge inside divided by epsilon naught. Now as the total charge inside the sphere is 0, therefore the electric flux through this blue sphere will also be equal to 0. And thus the electric field inside the sphere will also be equal to 0 as there is no charge inside the spherical shell that we have considered. Therefore, for hollow conducting, hollow non-conducting and for solid conducting spheres, the electric field inside the sphere will also be equal to 0. Now for outside the sphere, let us consider another spherical shell out here. Here this blue circle represents the spherical shell that we are assuming. The radius of this outer sphere is small r and the sphere along which the charge is distributed has a radius of capital R. The surface area charge density of this inner sphere is sigma and the total charge is capital Q. Now the flux through this outer sphere will be total charge inside the sphere divided by epsilon naught, which will be equal to the closed integral of electric field through this outer sphere multiplied with the area vector dA of this outer sphere. Now we know that the electric field throughout this outer sphere will be constant and hence we can consider this electric field out of the integral sign. So E integral dA will be equal to total charge inside this outer sphere divided by epsilon naught. Now E into 4 pi small r square will be equal to sigma, that is total charge inside this outer sphere will be equal to the total charge on this inner sphere, which will be equal to the charge surface area charge density multiplied by the total surface area of this inner sphere. So this will be equal to sigma into 4 pi capital R square. The charge density multiplied by the total surface area of the inner sphere divided by epsilon naught. Now from here we can say that total electric field through this outer sphere will be equal to sigma capital R square divided by small r square into epsilon naught. This will be the formula that we will be using for solid conducting, hollow conducting and hollow non-conducting spheres for finding the electric field at a point which is at a distance small r from the center of the sphere and outside the sphere. Now we can modify this formula by substituting sigma equal to total charge divided by total area of this sphere. So Q into capital R square divided by 4 pi capital R square into small r square into epsilon naught. Now this capital R square and capital R square will cancel out each other, and rearranging this formula we get Q upon 4 pi epsilon naught into small r square. Now this formula is very much similar to the electric field due to a point charge at a distance r from the point charge. So we can also write this above formula as kq by r square. So this is simply the formula of a solid conducting, hollow conducting and hollow non-conducting sphere at a distance small r outside the sphere. So now let us practice a few questions, and these questions will be making your concepts more clear. The first question is, a spherical metal shell A of radius RA and a solid metallic sphere B of radius RB are kept such that the distance between their centers is capital D. A point P bisects the line joining their centers such that the point P is equidistant from both A and B. Find the electric field at point P, the height of the point P from the midpoint of D. Also find the relation between RA and RB if the electric field on the surface of A is alpha times the electric field on the surface of B. The charge on each sphere is considered as Q. Now we have two spheres, here the sphere A and here we have the sphere B. The distance between the centers of these spheres is capital D. Here we have a point P which is bisecting the line joining their centers. This point P is at a distance small d from both the centers, and here the line joining the center and point P is making an angle theta with the horizontal. So we need to find the net electric field at this point P, the height of this point P from the midpoint of this line, and we need to find the relation between the radii of these two spheres if the electric field on the surface of A is alpha times the electric field on the surface of B. So let's see. The electric field at point P due to sphere A can be given as simply kq by d square, which will also be equal to EB. Why? Because the charge on both the spheres are equal, and also this point P is equidistant from the center of both the spheres. So simply we can write EA equal to EB equal to kq by d square. Now if we consider this right angle triangle, then we can simply write small d as d by 2 cos theta, as this distance here is d by 2 and this angle is theta. So we can simply write d small d equal to capital D divided by 2 cos theta. Now substituting this value in the above equation, we can write EA equal to 4kq cos square theta divided by d square, which will also be equal to EB and which will also be equal to E. Now if we consider the net electric field at point P due to the electric field of both the spheres, then it will be equal to 2 into E sin theta. Now putting the value of E here, we can write the equation as 4kq sin 2 theta into cos theta divided by d square. Clear? Here we can write 2 sin theta into cos theta equal to sin 2 theta. We can use that formula and we can derive this equation of net electric field. Now for the height of this point P from the midpoint of this line, we can write height h is equal to small d into sin theta, which is equal to d by 2 cos theta into sin theta. Then we can write h is equal to d by 2 tan theta. This is the height of the point P from the midpoint of the line joining the two centers. Now we are given that is the electric field on the surface of A is equal to the alpha times electric field on the surface of B. Then kq by RA square is equal to alpha into kq by RB square. Thus we can derive the relation between RA and RB as RB square equal to alpha times of RA square. So we have solved this equation. We have found the net electric field at point P. We have found the height of the point P from the midpoint, and we have also found the relation between RA and RB as per the conditions given in the equation. Now let's move on to the next question, which has already come in JEE Advanced 2009. Let's read this question first. We have three concentric metallic spheres, capital R, capital 2 times capital R and 3 times capital R as their radii. The charge on all these spheres are Q1, Q2 and Q3 respectively. It is found that the surface charge densities on the outer surface of the shells are equal. That means the total charge divided by total area for all the spheres are equal. Then we need to find the ratio of the charges on these spheres. Now, as per the conditions given in the question, we can visualize the situation as this. Here we have the smallest sphere Q with charge Q1, then we have the sphere with radius 2r and charge Q2, then we have this green and the biggest sphere with radius 3r and charge Q3. So first of all, we need to see the distribution of charges over the inner and the outer surface of all these spheres. Fine. We need to find the distribution of the charges over the inner and the outer surface of all these spheres. So let's see how we can do that. The distribution would be something like this. Now to understand this, we need to keep one thing in mind. We need to have one concept in our mind. The net electric field in a metallic conductor in electrostatic condition is always zero. I have already discussed this property in the lecture of electric field lines. You can click on the I button and find it out there. Now, if for example, if we consider the red spherical shell over here, and we have another shell that is the white colored shell inside this red colored of spherical shell, then we know that the net electric field inside this whole red spherical shell will be equal to 0. That means for that conditions, we need to have the net charge inside this red spherical shell should be equal to 0. The condition should be satisfied only when the net charge inside this red spherical shell is 0. Now, because of this blue sphere, we have the charge Q1. So, to nullify the effect of this Q1, we need to have the charge on the inner surface of this red sphere as minus Q1. Also, as the total charge over the surface of this red sphere is Q2, therefore to balance out, the charge on the outer surface of the red spherical shell should be Q1 plus Q2. Fine. The net electric field inside this red sphere should have been 0. For that, the net charge inside this white shell should have been equal to 0. And for that, we need to have the net charge on the inner surface as minus Q1. Also, as given in the question that the net charge on this red spherical shell is Q2, therefore to balance out this minus Q1, we need to have the total charge on the outer surface as Q1 plus Q2. Understood? Similar way, we can also find the distribution of the charge on the outer and the inner surface of the green sphere with radius 3r. Now, we are given in this question that sigma 1, sigma 2 and sigma 3, that is the charge distributions, the charge densities of all the three spheres are equal. Thus, we can write sigma 1 equal to sigma 2. That means Q1 upon 4 pi r square is equal to the charge on the outer surface divided by the outer surface area of the middle sphere. And solving this equation, we get Q2 equal to 3 times of Q1. Similarly, we have sigma 1 equal to sigma 3. That means Q1 upon 4 pi r square is equal to the total charge on the outermost sphere divided by the surface area of the outermost sphere. Solving this equation, we get Q3 equal to 5 Q1. Now, Q1 is to Q2 is to Q3 comes out to be 1 is to 3 is to 5. So this is the answer of the question. Now in the next lecture, we are going to discuss electric field due to solid spheres along with some JEE PYQs. So that's all for today. I hope you all understood whatever I tried to make you understand. I hope you all enjoyed this video. Whatever doubts you have, you can comment in the comment section, or you can DM me in my Instagram ID. The link is in the comment section. So see you in the next lecture. Till then, bye bye, take care, and Jai Hind.